We went from the PPWR and a very intensive discussion about this to the electronics, and now we are switching to the construction and building material sector. So the construction and building material sector is a very different one from the packaging sector, because packaging you have got a high mass and a real big flow, so short cycle times, and the construction sector is definitely different. So I'm very eager to listen to the next panel. So welcome on stage Charlotte Röber. She will be the host for the next 30 minutes, and we are going deep inside this topic. So our panelists are arriving. Okay, I thought from the left side, now you're here from the right. So please, it's your stage. No problem.
How do I move this?
Let me go to see. Doesn't matter.
Okay, so let's get started. Good morning, good afternoon. It's a bit in the middle of the day, so let me welcome you to this expert panel on building and construction. We have with me here Rudy Miller, who is Vice President Vinyls Business and Head of Circularity at Vynova. Hi, Rudy. And Eric Romas, who is Head of Project Circle at INEOS Inovyn. And both of them will give us a brief talk now on innovation and some facts on PVC in the building and construction sector. My name is Charlotte Röber. I'm Managing Director of VinylPlus. That's the sustainability commitment of the PVC value chain here in Europe. And let me set the tone a bit for what we're going to look at now in the next few minutes. So you can see here, PVC is one of the most recycled polymer in Europe, and actually, let me add in relative terms, also in the world. We had 35% of the available waste being recycled last year. That was 2024. And if you take a look here a bit on the picture, you can also see which applications are in the spotlight. So you have windows, you have flooring, you have cables, and all of these are, as you know, building and construction applications, and are also used in these applications later on again. So let's now have a look at what we know about the innovations, the purpose, the functionalities of this polymer in the sector. And we'll start with Rudy. I'll give you the clicker, and you're good to go.
Thank you, Charlotte. So nice to see a lot of people here, some familiar faces, some new faces. That's always great. Yes, indeed, as Charlotte was saying, PVC is one of the most recycled materials out there. And certainly in construction, as you can see in this slide on the left side, you see where the recycled materials are actually used, which applications are used. And you can see that indeed there's a lot of recycling going into windows, profiles, floor covering, all of course applications that are relevant to building and construction. So as long as PVC can be collected separately, can be collected close to the source, and can be processed directly through different recycling techniques, from mechanical, which is already quite widely available today, but also to other physical or chemical solutions that will develop a bit more. Eric will talk a bit more about that. PVC is 100% recyclable in these applications, not only once, but up to 7, 8, 9 times in a row. So the effective lifetime of PVC in applications is not measured in days or weeks or months, it's measured in decades and up to centuries if you take into account the multiple recycling possibilities of PVC. So of course that doesn't mean it's all easy and a straightforward path forward. We do need to have simple, harmonized rules to be able to collect, source, and eventually recycle PVC to make sure that this can contribute to the affordable housing and sustainable housing of the future. I would strongly advise you to if you want to learn more about all the infinite possibilities of PVC in different applications, not just construction, to visit the site here, and there's a very nice interactive map is available for you to look at the different ways PVC is used today. Always quite interesting. So why do we talk about PVC in terms of affordable and sustainable housing? Well, first of all, it's a very cost-effective, very carbon-effective material. It's been used for decades in the PVC industry, and as with any application, you only use a material if it matches the cost and performance characteristics that you need in those applications. So there's no mistake in looking at why PVC is the most used plastics in the construction. It's because it fits the purpose. It's the best cost-effective way to meet the performance requirements. It has a proven long-lasting and safe lightweight performance in many applications, including windows and doors, but not only. It is a very low maintenance product once installed, whether you talk about windows and doors, but also external applications, flooring, a simple wiping of the surface will return it to its perfect state, instead of having to regularly maintain, use varnishes, paints, etc., which can also add to the cost of living in a house. So the low maintenance is quite important. It has outstanding thermal insulation. So basically, affordable housing means also affordable cost of living once you've built and live in the house. And from that perspective, saving energy. We all know the energy costs are not going down. So efficient energy use is extremely important in affordable housing. And PVC certainly is a lead contender there. The footprint is low to start with. So in terms of sustainability, PVC is a unique plastic. It has only 50%. It only depends on 50% of fossil feedstock to start with, which is a nice sustainable feature. And it's, as I said, 100% recyclable in multiple types of technologies. Many of you will be familiar with mechanical recycling, which is again very widely used in Europe. The industry took the leadership more than 20 years ago to voluntarily start recycling and putting infrastructure in Europe to collect and recycle PVC, give it a second, a third, and a 10th life. But there are also new developments and exciting technologies that will address not only the harder to recycle materials, but also some potential evolution of regulations that might drive us to contemplate these technologies. So I'll pass it on to Eric for the next portion of this speech.
Thank you, Rudy.
Same for me. Thank you very much, Rudy. And indeed, if we look to PVC, yes, it can be recycled for 100%. So let us speak about the advanced recycling. What does it mean, PVC advanced recycling? It's about the physical recycling and the chemical recycling. So if you look to the physical recycling, that's about the dissolution technology. So there you remove any impurities. Today a lot of development to extract also the legacy additives. So it's complementary to the mechanical recycling. And if you look to the CO2 footprint, of course, mechanical recycling is the best one. And all the waste that can be recycled mechanically must go to the mechanical recycling. That's for sure. Also CO2, it's the best recycling technology. Next to it, the dissolution technology. Depolymerization, unfortunately for PVC, that's not feasible. So then we come to the chemical recycling, and there we look to the pyrolysis. Pyrolysis technology, lately it has been shown that you can process a feedstock of polyolefins with 10% of PVC waste. So pyrolysis technology is available today, and this is to work with diluted PVC feedstocks. Using 10% of the PVC in the feedstock results in a pyrolysis oil that can be processed on a steam cracker. So this is really a first of its kind. So for that reason, pyrolysis technology also coming up after the dissolution technology. What about the gasification technology? Also there are a lot of developments that are going on. And this technology has been used already previously. I will show it on a next slide as well. But if we look from the right to the left, okay, I spoke about the CO2 footprint, so it's going up. So when we go from pyrolysis to gasification, also the CO2 footprint of the gasification is higher than the one of the pyrolysis. Last but not least, what about investment? Investment is also going up from the right to the left, meaning mechanical to the gasification. The investment goes up. So, what is today's status of the development to recycle any type of PVC waste? Like I said, the physical and chemical recycling is complementary to the mechanical recycling. So we are focusing with these technologies on composites and on the PVC waste that is containing the legacy additives, because these feedstocks, waste of PVC, cannot be recycled mechanically. So what has been done by VinylPlus, like you know, VinylPlus is very active in this domain, so we need to encourage them, of course, and they are doing a lot of founding. So here you will see on the slide the different foundings that VinylPlus is doing. So it's the VinylPlus mat, it's the Ray Vinyl floor, the Phoenix prototype, and this prototype is to develop a technology to sort PVC waste that is containing lead and non-lead. So when they sort it out, the PVC waste not containing lead is made available for the mechanical recycling, because there it should go. And then, of course, the waste that is containing the lead, that waste is good for the dissolution and for the pyrolysis or gasification. So dissolution technology. We as a company, Inovyn, we are working on this kind of development, but we cannot do it alone. We need also other developments. So fortunately, when we look to the other members of VinylPlus, other members are also working, and they presented already the results as well during different conferences. So this is really good to see that different companies are working on the dissolution technology, because installing an industrial unit by each company means that we can increase, of course, the overall capacity to recycle more PVC waste. Pyrolysis, well, I told you already about it, but there was a project founded by VinylPlus, and this is about the pyrolysis technology of Arcus Green Cycling. They operate in Germany a demonstration unit of 4,000 tons per year, and so far they were processing MPO. VinylPlus asked them to show that they can process a feedstock containing 10% of PVC waste. And that's what they have done. They did not do it directly on the demonstration unit. First, they have done it on a bench scale unit. And it was also a good success on the bench scale. And then they have shown it on their demonstration unit. So this is really what I said, a first of its kind. This technology can accept 10% of PVC waste in the feedstock. Last but not least, if you know about the pyrolysis, you would say, yeah, nice, but what about the pyrolysis oil? Because when we have PVC, we have chlorine, we have perhaps aromatics, we have oxygenates, and so on and so on. The University of Ghent, Professor Kevin van Geem, he asked a sample, he has analyzed the sample himself, and then he concluded that indeed this quality that was made with 10% of PVC waste in the feedstock is good for processing on a steam cracker. So once more again, third time that I will tell you, this is really a first of its kind. Gasification, another founding of VinylPlus. So you see that VinylPlus is really looking to the different technologies to recycle the waste that cannot be recycled today mechanically. So there is now a project for the gasification, a project with a German company, Ecoloop, and there we will be, VinylPlus will be doing the same as they have done with Arcus Green Cycling, showing that adding 10% of PVC to the gasifier feedstock will also end up in a success. So for that project you need to wait, because that project is just launched. So then that was all on my side. Back to you.
Perfect. Thank you very much to both of you. Very perfect timing as well, which means we have a lot of time for questions. Rudy, you told us a lot about the properties of the material, how it can be used, and what the specifications are. And Eric, you talked a lot about recycling and the different options that there are. Now I take a glance here at the audience. Do you have specific questions already on one of the two presentations that you would like to bring? Was it all so clear that there are no questions left? There's one. Yes, you'll get a microphone.